Greetings, Saintsmen. This is lesson 6.3 regarding medians and altitude. So some other ways for us to consider the lines of concurrency that we can have within a triangle to create that concurrent point as we try to find the middle. So for the median is a segment with endpoints that are a vertex. So we're going to go from the angle. It's going to be a critical thing for today's lesson. That are from a vertex and a midpoint of the side opposite. I hope quickly we're going to get comfortable with the notion of sides opposite. It should be something that's rather intuitive, but let's go ahead and just sketch this triangle. This guy's named A, B, C. Now from A, what's going to be opposite, right? So from this vertex, the side opposite is BC. So BC side is opposite. Vertex A. All right. So from there, we're going to construct this midpoint, right? So BC, this side opposite, this point I'm going to call M. It's the midpoint. And again, from the angle, from A, that's how we're going to construct this guy. So point of concurrency. Now, I'm not going to construct all three of these because it's going to make the diagram rather busy. It's more so that I just want you to be able to see roughly where this guy's going to happen. This is our point of concurrency right here, constructed. That will be the result of three of these medians. It has the name of, it's called a centroid. Okay, and the centroid has the following relationship within a triangle. Works like this. The centroid is 2/3 of the distance from the vertex to the midpoint opposite the vertex, and that's going to be on the median. In other words, AX from the vertex to the centroid is equal to 2/3 of the length of that entire median, which would be line segment AM. This is rather straightforward, and I don't want you to overthink how to do this problem. So let's consider this problem. If I were to say that if line XM is equal to 5, then we're going to solve for AX and AM. Okay? Super straightforward. If XM is 5, well, again, XM is going to be 1/3 of the entire median. AX is 2/3 of it. So then the entire, the other half has to be, the other portion has to be twice as long. In other words, AX is going to be 10. And AM is going to be 15. That's that. All right. Don't overcomplicate those problems. 2/3 and 1/3. One other way for us to do this. Again, we're going to be working from the angle, okay? So our last way that we're going to be considering these lines of concurrency is that if we draw from the angle, from the vertex, a line that's going to be perpendicular to the other side. This has a special name. It's a height, right? It's going to be the greatest length that's a right angle from that side. It's also going to be the shortest length from any of these, from this vertex to any other point on the side opposite. So from the vertex to the side opposite, that's constructed perpendicularly. This is what's known as the altitude. It's that height. There is a name for this point of concurrency. You construct three altitudes. The point of concurrency is called the Orthocenter. Now, the Orthocenter is going to come up on your next quiz, okay? In fact, let's go ahead and We're going to have the concurrent lines. Then we're going to have the name of the point of concurrency. Okay. We dealt with the perpendicular bisector, which resulted in the circumcenter. Then we had the angle bisector that resulted in the incenter. Today, we've discussed the median, which resulted in the centroid. And then, of course, the altitude, which we just discussed. Oops, let's go ahead and fix the spelling at altitude. The altitude, which constructs the orthocenter. First 4 questions of your next quiz is this. You are going to be given, of course, these 4 terms, concurrent lines. You will need to supply me with this. It will be just a fill in the blank. You need 4 words. Again, first 4 questions of your next quiz. One of the questions on your quiz will be to find the orthocenter, which works like this. We're going to find the orthocenter for JKL, given J at -2, 4, K at 4, 4, and L at 1, -2. Now, for the sake of the example here, I'm going to avoid working with JK. In other words, I'm not going to work from L. And it has to do with what we came up with the other day. On those 2 points, you guys can see that they have the same Y value. So it's the X that changes. So to have the same Y value, that's going to be a horizontal line. It'll have a slope of 0, and then the perpendicular line, which we're going to be interested in, right? Because altitudes had a perpendicular relationship. That's going to be undefined, and I don't want to work with that. Again, that's that whole notion of being easier done than said. Now, what I can do, of course, is that I can graph this, but this is not part of the solution. All this is going to do is give me some sort of orientation as to what my figure looks like. So here we go, -2, 4, right? So that's J. 1, 2, 3, 4, 4. That's going to be K. And then we have L, which is 1, -2. Okay? So what you need to understand is that we're going to work from one of these vertices. Again, from the angle, from the vertex to the side opposite. So the first one we're going to work with is going to be from J. The side opposite is K. The slope of K, I'm sorry, the side opposite is not K. The side opposite is KL, right? It's just the leftover letters. We solve for the slope of KL, which, again, if you guys put that through the slope equation, right? Y sub 2 minus Y sub 1 over X sub 2 minus X sub 1, okay? I'm not going to go through that entire calculation for you, but the slope of KL is going to be 2, meaning that the perpendicular slope, or the altitude slope, is perpendicular, being it's the negative reciprocal, -1 over 2. Now, using point slope, point J, slope, -1/2, right? Y minus Y sub 1 equal to M times the quantity X minus X sub 1. So in other words, Y minus 4, right? We're still working here, over here with J, right? So Y minus 4 is equal to -1/2, that's my slope, times the quantity X minus, because it's -2 minus -2, which is +2. And now I'm going to solve for Y. Y minus 4 is equal to -1/2 X. -1/2 times +2 is -1. I'm going to add 4 to both sides. Y is equal to -1/2 X. -1 plus 4 is +3. So that's one of my equations. Now I worked from J, right? It's this line. Just to give you some sense about it, it's this guy right here. That's my altitude, okay? From that point to the side opposite perpendicularly. And I only need to do 2 of these. Remember, deductively, we figured out, actually through those circumcenter problems, that we only need to do 2 of the 3 because the third one will connect anyway. So we need to just find one other equation. Remember, an equation like this, a linear equation in a coordinate plane is going to result in a line, the intersection of 2 lines being at a point. So we're going to work from this time, instead of from J, of course we need another point. I'm going to skip L because, again, it's this issue. I don't want to deal with undefined or 0. Not that it's hard, just so I'm not doing it. I'm going to have k. It is confusing for some people, and this is a more consistent method of solution. Slope opposite k is going to be the leftover letters, JL. If I actually run through y sub 2 minus y sub 1 over x sub 2 minus x sub 1, I will get negative 2 as my slope, right? So then, therefore, my altitude slope, which is perpendicular, is going to be the negative reciprocal of negative 2, which is just 1 over 2. Boom, there's my slope. Go back over here. Here's my point, which is k, 4 comma 4, right? So y minus 4 equal to 1/2 times the quantity x minus 4, right? And then I'm just going to solve for y. I'm going to distribute y minus 4 is equal to 1/2 x. 1/2 of negative 4 is negative 2. Plus 4 plus 4. Y is equal to 1/2 of x. Negative 2 plus 4 is positive 2. So then there I have it. I have my two equations. Now, I'm going to line these guys up next to each other. This methodology should look similar to you from what you did with the circumcenter when you got to the end. You have two linear equations. I have these two equations that I yielded. Remember, both of these things equal y, therefore they're equal to each other. Negative 1/2 x plus 3 is equal to 1/2 x plus 2. I'm going to add 1/2 x to both sides. Because I'm going to solve for x. I have 3 is equal to 1/2 x plus 1/2 x is 1x or just x, right? Then I'm going to subtract that 2 off, and I have 1 is equal to x. That's my x coordinate, or the x portion of my ordered pair. Go in, let's plug it in one of these. Y is equal to 1/2 times, right? I substituted in 5 for x, plus 2, right? Why did I substitute in 5? I didn't do that. I substituted in 1. My apologies. 1 for x. 1 times 1/2 is 1.5. So I want 1/2 plus 2, which is going to be equal to 2.5. Gentlemen, there we go. There is my orthocenter. It is the coordinate x, which is 1, comma 2.5, which is y. And there it is. When you do these problems on your homework, make sure that you do not worry about in, on, or outside of the triangle. All I want you to do is just solve for the orthocenter. I'm going to post another video, or 2 more videos. Some is going to be with your quiz review. It's going to be a portion of it, doing more circumcenter and orthocenter problems, as well as what's going to be done in class on the week of January 19th. So if you have any questions, please feel free to contact me via email. Good luck.